Hi guys, I hope things are going good. This is the second half of your endothermic exothermic lecture, recorded from the privacy of my very own home office, not at school. I hope that things are going good for you guys at home. I just want to remind you of a couple things. Number one, you can always email me at any time if you need help. And number two, I am having Zoom office hours from 11 to 12 every Thursday. I sent out an email, and I will also post that information in Schoology for you. Also, at the top of the thermochemistry folder in Schoology is a document that says Lesson Plan for Thermochemistry. If you open that document, you can see everything that we are going to be doing from now until the end of the year. That way, if you get behind or if you want to work ahead, everything's in there. And I will be putting the things, I already have put everything in order in the thermochemistry folder in Schoology so that you guys can see it and you can access it at any time. Also, I know we've been having trouble with Schoology, so if any time in the next couple weeks you run into trouble, please email me. Or also, if you need to access your documents and you've already made them, remember that those documents are also saved in your Google Drive, so you can go to your Google Drive to access them there. So I sent you guys out a link for the copy to the endo-exothermic notes. And I believe that Schoology, the Google app assignment button was what was not working. I believe they've got that fixed. I've been using it today. Today is actually Friday. But if it's not working for any reason, you should have the guided notes that you can go ahead and finish out the second half of this lecture on, and we'll go from there. We're just going to do whatever we can do to get through this together. All right, so today we're looking at the flow of energy, heat, and work. Remember that I told you that there is no such thing as cold, that hot and cold were adjectives, and that heat flows from the part of greater heat to the part of less heat. So if we're going to talk about heat flow and how that works, the first thing we need to talk about is how is heat measured? Now, if you were here, I would say, okay, so how do we measure temperature? Tell me three different ways that we would measure temperature in. And hopefully one of you would say Fahrenheit, and I'd say yes, but we don't use that in science, so tell me the other temperature, and you guys would say Celsius, and I'd be like, that's right, exactly. And then I would ask you for the third temperature, and hopefully you remember that it is Kelvin, and each of those is a different unit of temperature. So heat flow, or the way that we measure heat in, is typically measured in two common units, the calorie and the joule. Now, you've maybe not heard of joule as much, but the calorie, I'm sure you have heard of, because when people are trying to gain or lose weight, or we talk about how much food you should eat, typically we talk about calories and what your intake should be. Remember that heat is a form of energy. Therefore, calorie and joule are the ways that we measure heat. The energy in food is usually expressed in calories. So 1 calorie equals 1 kilocalorie equals 1,000 calories. Just like every other scientific explanation that has a kilo in the front, remember that kilo means 1,000. Just like 1 gram equals 1 kilogram equals 1,000 grams. 1 calorie equals 1 kilocalorie equals 1,000 calories. You've probably typically heard from different people that the average person should intake approximately 2,000 calories per day. That they say that the average person in the United States weighs about 150 pounds. So if that is you, you are at the 2,000 calorie mark. If you weigh less than 150 pounds, your calorie intake should be a little less. And if you weigh more, it's probably a little more to maintain the same weight that you are at right now. So on what two factors does the heat capacity of an object depend? Heat capacity, the amount of heat that an object can hold, depends on both its mass and its chemical composition. So how much mass it has and what type of mass that is, or what it is made up of. The amount of heat needed to increase the temperature of an object exactly 1 degree Celsius is the heat capacity of this object. So however much heat it takes to increase the temperature of that object 1 degree Celsius is the heat capacity of the object. The specific heat capacity, or simply the specific heat of a substance, is the amount of heat it takes to raise the temperature 1 gram of the substance 1 degree Celsius. We're going to come back to this equation in just a second. I want to look at this chart first. So the specific heat is how much it takes, how much heat it takes to raise 1 gram 1 degree Celsius. And you can see that the calorie is super easy. It's 1 calorie. So it takes 1 calorie to raise 1 gram of water 1 degree Celsius. That is the specific heat of water, is 1 calorie. We also use 4.18. That is a specific heat when we are talking about joules. When we are not referring to food, we typically use this column, or the joule column of specific heat. That is the more typical way, and that is the way that majority of scientists measure heat. The calorie column over here on this side is what we typically use when we're talking about food. All right, I want to go back 1 slide to this right here. So this is the equation that we are going to be using, where we are going to be inserting our math information into heat capacity and specific heat. So I want to talk to you about what the different variables mean in this equation. All right, I already introduced to you that heat is represented by the letter Q right here. So your heat, whether it's in joules or calories, is represented by the letter Q. M stands for mass, and delta T stands for change in temperature. Remember that the delta symbol, which is the Greek symbol for change, delta T, that means the change in temperature. And C is your heat capacity, or specific heat. Specific heat capacity is what C is represented by. Now, there's another way to write this, and this is the way that I remember it, so I wanted to make sure and show you. This is just a rearrangement of the equation. Q, remember that Q equals heat. Q represents heat, equals M, which is mass, C, specific heat, and delta T is change in temperature. I remember this as Q equals MCAT. That's the easiest way for me to remember it. If I write it down like this, I can always rearrange it back to the other way, which was, I'm not very good at this Jamboard. It's brand new, so bear with me here. C equals Q divided by M times delta T. So these are both the same equations. They're just written 2 separate ways. I tend to remember this one right here because it's easiest for me, but you can use whatever works the best for you. All right, so back to our PowerPoint. Now, remember that we are talking about exothermic and endothermic relationships. Remember that in the endothermic relationship, the heat flows into the system. The exothermic relationship, the heat flows out of the system. When you guys are doing your problems for this, we're going to do a practice problem together, but when you are doing your problems, it's really important that you remember that if you have if your heat is positive, if your Q number ends up being positive, that means you have an endothermic reaction and the heat is flowing into the system. If your Q number, or your heat number, is negative, that means you have an exothermic reaction because your heat is flowing out of the system. All right, so calculating the specific heat of a metal. Here is a practice problem. If the temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 degrees Celsius when the copper absorbs 849 joules of heat, what is the specific heat of copper? Okay, so let's look at that together. I'm going to erase this. Nope. Go away. All right, we'll start with this. So Q equals M C delta T. And what we know from the problem was we know that Q was 849 joules. 849 This would be easier with a touchpad, but I don't have one. Joules. Mass, which is in grams for this problem, equaled 95.4 grams. And then delta T, it tells us that the temperature went from 25 degrees Celsius to 48 degrees Celsius. So we're just going to subtract that. The difference between the two of those, difference means subtract. So 48 minus 25 is 23 degrees. Then we are simply, so what we are solving for, or what the question was asking for, is the specific heat, which is represented by the C. So we're going to say, we're going to rearrange our equation, and we're going to say that C equals Q divided by mass times delta T. And now all we're going to do is plug our numbers in. So Q is 849 joules divided by 95.4 grams times 23 degrees Celsius equals C. And then all you guys have to do is do the math that goes with that. Remember your order of operations, PEMDAS, so you have to do the multiplication first before you divide. If you don't, it will be wrong. Remember that if you are plugging into your calculators, all this at once, it would be 849 divided by parentheses 95.4 times 23 close parentheses. If you do not use the parentheses on your calculator, it is going to go 849 divided by 95.4 times 23, and it's going to give you the wrong answer. Okay, so back to our presentation. It's going to walk us through this problem, but I just wanted you guys to be able to see me walk it out, write it out. So it tells you, list the knowns and unknowns first. So your mass is 95.4, your delta T is 48 degrees minus 25 degrees, which is 23, and your Q is 849, and then you are looking for the specific heat of copper, because that's what your material is. So all you have to do is put your numbers into the equation like we just did and solve, and you get 0.387 joules. Now, gosh, you guys are doing this on, I don't even remember what day. The next thing that we have assigned is practice these type of practice problems. Don't forget that I am going to have Zoom office hours from 11 to 12. If that doesn't work for you, or you just want some one-on-one help, or you need to meet at another time, just send me an email and I will set up a time with you. Or if we can ask the question over email, we can do that too. Whatever works for you guys. Reach out. We want to make this as seamless as possible for you. I know it has been frustrating. It's been frustrating on my end. My own kids have been frustrated. But we are here for you. We miss you guys, and we want to make the rest of this year as awesome as we possibly can. And we'll talk to you soon. Bye.